Today I want to tell you about a really cool new 3D printing device created by researchers at the University of Toronto. This handheld device incorporates 3D printing technology, but instead of using polymers or resins to create plastic parts for a contraption, this prints out, quote, a biomaterial or tissue sheet from a microfluidic cartridge, unquote. This biomaterial is basically a thick ribbon of collagen, fibrin, and hyaluronic acid, which contains an embedded layer of skin cells. All of this is stored in a container of so-called bio-ink that gets rolled out onto the wound surface. The whole contraption is about the size of a shoe. The device weighs about 0.8 kilograms, so it's very light and very portable. This means that it can be carried on hand by rescue workers, like firefighters who might need to help someone with burns, or a forest ranger who finds an injured hiker with lacerations out in some remote part of the wilderness. The rate of printing is also pretty quick. The device can create a strip about 3 or 4 millimeters wide and 6 inches long in about 15 seconds. So it can theoretically be used to fill large, deep wounds with this biomatrix within a matter of minutes. The researchers that developed this technology were led by PhD student Navid Hakimi and Associate Professor Axel Gwenther of the Faculty of Applied Science and Engineering at the University of Toronto. Professor Gwenther said, in a quote, "Most current 3D bioprinters are bulky, work at slow speeds, are expensive, and are incompatible with clinical application," unquote. Now this new device, as far as I can tell so far, seems to solve pretty much all of these problems. It's small and thus portable, so it can be taken into extreme rural areas to help people who are very far from a hospital. It's relatively quick, too. It can be applied immediately, and it prints out replacement skin at a pace that's slow enough to be steady, but fast enough to be practical. It's got actual real-world utility. That's really cool when you are talking about one of these new inventions, because a lot of these new inventions, oftentimes they have to go through a lot of testing and a lot of re-engineering before they become practical. And now, when you compare this device with its printed out layers of skin to a graft treatment, which uses donor skin that's been perforated and stretched to cover a larger area, this device provides more effective coverage of the wound. And that leads to better health outcomes. It leads to a better healing process. All in all, this is an incredible little piece of technology. The researchers are now working to improve it, trying to make it print out the skin biomatrix at a faster rate, and to print out a wider strip so that it can cover more surface area faster, and be that much more effective. Once the technology has been optimized, it can be put through clinical trials in humans. Assuming it effectively heals wounds, instead of just clotting them with goo, this could be a product that has huge potential. It could vastly improve on-scene wound care for patients who've suffered burns, or scrapes, or lacerations, or punctures, or any other kind of soft tissue damage.